Ever wondered why mountain weather changes so rapidly? In this video, we delve into the fascinating world of highland climates, exploring how altitude and topography create unique weather patterns. From the snow-capped peaks of the Himalayas to the arid Tibetan Plateau, discover how elevation shapes climate and vegetation in ways that latitude alone cannot explain. Stay tuned to uncover the secrets of these diverse ecosystems. Welcome back to the channel. Today we're taking you uphill, literally. We're exploring highland climates and why they're some of the most diverse and fascinating environments on Earth. From the chilly peaks of the Rockies to the towering Andes and across the Himalayas, mountain climates reveal just how dramatically elevation can shape the atmosphere. So, let's get into it. To start, what exactly is a highland climate? Highland climates represent a special category in the Koppen climate classification system, denoted by the letter H. These climates are found in mountainous regions and are distinctly different from the surrounding lowland climates. Unlike other Koppen zones that span wide, relatively uniform areas, highland climates are characterized by sharp variations in temperature, precipitation, and vegetation over short distances. Even over short distances, climate conditions can change rapidly. That's why you won't find highland climates represented neatly on a world climate map. It's more of a mosaic than a zone. These climates are found in places like the Rockies, Sierra Nevada, Andes, and Himalayas, and in parts of Africa like the Ethiopian Highlands and Atlas Mountains. So, what makes highland climates so unique? First and foremost, temperature decreases with altitude. Every 300 meters, which is about 1,000 feet you climb, the temperature drops by roughly the same amount you'd experience traveling 300 kilometers northward. That means climbing a mountain can simulate a journey from desert to tundra in just a few hours. Take Arizona. Phoenix sits in the desert at 338 meters, averaging 34 degrees Celsius in summer. Head north to Flagstaff at 2,100 meters and you'll find a cool 19 degrees Celsius, a full 15 degrees Celsius difference, yet their seasonal cycles are surprisingly similar. Now, let's talk about precipitation. Mountains play a major role in shaping rainfall patterns through a process called orographic lifting. When moist air is forced to rise over a mountain, it cools and condenses, producing precipitation. A striking example of this occurs in the Himalayas. The southern, windward side of the range facing the Indian subcontinent receives intense rainfall during the summer monsoon. As that moist air is pushed upward, it dumps heavy rain and even snow on the slopes. But cross over to the other side, into the Tibetan Plateau, and conditions are completely different. Much of the moisture has already fallen, so the leeward side becomes dry and arid. That's why the Tibetan Plateau, despite its high elevation, is classified as cold and semi-arid. So, the Himalayas don't just block winds, they redistribute precipitation, creating sharp contrasts between lush, forested foothills and dry, barren highlands. But here's where it gets even more interesting. Highland climates don't just change with altitude, they also shift with exposure, slope orientation, and wind direction. Let's take a closer look at slope orientation. In the northern hemisphere, south-facing slopes receive more direct sunlight throughout the year. As a result, they tend to be warmer and drier. Meanwhile, north-facing slopes get less solar energy, staying cooler and moister. This contrast can dramatically influence vegetation, snow cover, and even human settlement. A clear example of this is found in the Alps, particularly in Switzerland. South-facing slopes above the Rhone Valley support vineyards, chestnut trees, and sunny alpine villages, ideal for agriculture and tourism. But just across the valley, the north-facing slopes stay shaded and cooler for much of the day. Here, you're more likely to find dense conifer forests, longer-lasting snow, and less intensive land use. So, even at the same elevation, two slopes can host completely different climates, all because of the sun's angle. And this variation only adds to the complexity of highland environments. And let's not forget the wind. In mountainous areas, wind patterns don't always follow the large-scale systems we see on weather maps. Instead, they're often shaped by local topography, especially in the form of mountain and valley breezes. During the day, sunlit slopes heat up quickly. Warm air rises along the mountainsides, pulling cooler air up from the valley. This is known as a valley breeze. At night, the process reverses. The slopes cool rapidly and cold. Dense air flows downslope into the valley, creating a mountain breeze. A real-world example? Look no further than the Kathmandu Valley in Nepal. Surrounded by the Himalayan foothills, the valley experiences daily upslope winds during the warm afternoons, especially in summer. These breezes bring cooler air into the valley and help disperse air pollution that tends to build up in the mornings. By contrast, overnight mountain breezes carry that cooler air downslope, often forming temperature inversions that can trap fog or smoke in the valley floor. This daily wind cycle may seem subtle, but it plays a critical role in the local climate and air quality, and it's just one more reason why highland weather is so dynamic. So yes, changeability is the rule here. As you climb, it's not just the climate that changes. Vegetation does too. This is called vertical zonation. It's like a compressed version of traveling from the equator to the poles. At the base, you may find semi-arid shrubs. Go higher and you'll hit chaparral, then pine and fir forests, followed by tundra, and finally, permanent ice and snow. All of that in less than 13,000 feet of elevation. So why should we care about highland climates? They're not just scenic. They're biodiversity hotspots, climate buffers, and vital sources of fresh water. Plus, they give scientists a natural laboratory to study how temperature, wind, and sunlight interact across small areas. And remember, altitude matters as much as latitude. That's why you can find polar conditions in the tropics, if you just go high enough. If you're enjoying this breakdown of the world's most unpredictable climates, do me a quick favor. Like this video if you learned something new, and subscribe for more weekly explorations into Earth's wildest climates and ecosystems. Next time you see a mountain, think of it as a climatic staircase, each step offering a new world. Thanks for watching, stay curious, and I'll see you in the next one.